Hey folks, welcome out here this great afternoon. It is TNLearn Summer School. Yes, TNLearn Mathline Summer School time here, all right? I'm Ernie Roberts. I'm your host for this afternoon session. We are so glad that you have tuned in to be with us today. And, you know, it's just part of summer school. We're going to have a little bit of fun. We're going to look at some apps. We're going to look at some good things today. But you know what? You make it rock always. We say that. But you don't need to call in today. But what you do need to do is get that pencil, get that paper. Let's write some problems down. And you know what? Let's have some fun. Sit back, relax, and let's do some good math. What's our topic today, guys? What are we going to be looking at? How about some geometry apps? Basically, apps, applications. We've been looking at radicals. Now we're going to apply a few things, all right? We want you to realize that they're not just these crazy things that we can do to numbers, all right? Which we can do. We can do that. But they do have some rationality out there, and they are used. Notice I said rationality because a lot of times they come out irrational, right? So let's take a look at our first problem and see where we're going to go in this problem, all right? It says the area of a circle is 45 pi. Find the measure of the radius in radical form and to the nearest tenth. I'm even going to go a little further on that radical form. We're going to make it the simplest radical form, all right? We can leave it as a radical, but we want to simplify. We want to always simplify. Keep that in your mind, folks. Always when you see a radical, can we make it more simple or simplified in this case? So let's see what we got. We got a formula for the area of a circle. We all know that. If we don't, we're going to learn it right now, all right? Area of a circle is pi r squared, all right? That's our formula. Pi is basically another irrational number. Wow, there are a lot of those out there if you haven't figured that out by now. There are quite a few out there, and we tend to use it as about 3.14, 3 and 1400. Sometimes we add another decimal place to it and such. Sometimes we just call it 3.1 or 3. But those are approximations. This pi actually rambles on and on and on and on and on and on. Okay, sort of like I'm doing right now, isn't it? Yeah. So what we're going to do is we're going to place this 45 pi in the place of area, all right? Because that's what's going on here. We're putting our 45 pi right there in place of our big A. We're going to keep pi r squared to the right, okay? Because that's our formula. That's our formula. Keep in mind, we are looking to find out what is this r equal to. We've got numbers, some rational, some irrational, all right? We've got them all hanging out here together. We're going to see how can we get r by itself. That's the game plan here. So what I see is we need to divide by pi. So let's do it. Let's divide this side by pi. If you divide the right by pi, guess what we've got to divide by on the left? So let's do that also. Oh, division property of equality. We've got to love it. It's always there. It's always there. The pi's cancel, my friends. They cancel on both sides. So, hey, we lost some irrational numbers there. That always makes life a little nicer. However, we have a 45 and an r squared. We're about to create another irrational number, all right? Because the square root of 45 is coming our way. You say, Ernie, where did the square root of 45 come from? You just kind of jumped a little, didn't you? We're going to have to square root r squared to get to r, all right? And if we square root the right, we're going to square root also on the left. Now, I like for y'all to be able to kind of see where problems are going to go. That's why I kind of jump occasionally. But I like to come back and I'll say, here's what we did. Here's what we did. So you say, that's what we did. Now, remember what I said. You say, did you say something? I said a lot of things, haven't I? Let's look at this root of 45, the square root of 45 creature we've got here, all right? It's irrational. I cannot come out with a number times itself. Now, the factors of 45 are 1 and 45, 3 and 15, 5 and 9. None of those are a number times itself. None of those represent a number times itself. So the square root of 45 is not going to be found with just nice little integers or rational numbers multiplied together. We are going to need to get the same number. It's going to be very irrational if we try to use the decimal form. We'll get there in just a minute. Right now, let's go ahead and simplify this thing, all right? And let's bring it right over here. We've got the square root of 45, which I mentioned some factors. I mentioned 45 and 1. I mentioned 3 and 15, 9 and 5. The best combination to simplify this radical is 9 and 5, all right, because there's a perfect square lurking there. And you say, well, Ernie, 1's a perfect square. It doesn't help you any. It just lets you go right back where you started, all right? But 9 and 5 allow us to really simplify this. Let me see if I can get the right number in there. I'm already thinking ahead to square roots, folks. And what is the square root of 9? It's going to be 3. And here we go. 3 times the square root of 5. That is our radical form. That is simplified. This is a radical also, yes. But this is our simplified form. Again, we came from 9 times 5, which gave us this 3 times the square root of 5. All right? Now, let's check it out and let's see what that is in a decimal form. I don't even dare to guesstimate where it is. All right? Let's take it out here. Let's see. We've got, wow, how about it? We've got 3 times the square root. Find your square root button. It's right under the x squared button there, folks. And we put a 5 in there and we close that parenthesis. Be sure you do close it. And let's see where we're going. Enter. It's a little bit, it looks like about almost 6 3/4 and a little bit more than 6 2/3. Again, it's irrational. You see all those digits rambling on, and they still aren't finished. There's no pattern that's come in on that. If you notice all these digits, they just keep rambling on. We said we would round to the nearest tenth. So there is our point right there. We're going to cut everyone else off, all right? Everything beyond to the right of that 7, and that as an approximate value, and by the way, we're going to use this number here because we're rounding things off, is going to be around 6 7/10. That's our rounded off version, okay? And again, this is your radius. You're thinking of it, as I said, it's somewhere basically between 6 2/3 and 6 3/4 in terms of length if you were playing with your rulers, okay? So there's your story. There's your information. Simplest radical form, also to the nearest tenth. Basically, different ways to say the same number. Just remember that nearest tenth is just that. It's an approximation. It is not the exact root of 45, but it's pretty close, pretty close. All right, let's take a look at our next problem coming up here. This one talks about a square, and we think of a square as a quadrilateral with all 4 sides the same length. We call them congruent. In this case, the area, the space inside, is 50 square inches. Now again, I start thinking about 50, and I think of the number 50. I can't think of a number exactly times itself is going to give me 50, all right? In other words, some people say, well, you could use 25, couldn't you? Well, 25 times 25, that actually takes us all the way up to 625. So we're not looking for what we add. We're looking for something to multiply. We're looking for multiplication. So let's use the formula. The formula says the area of a square is simply a side times itself, or we'll call it side squared. All right, let's call it side squared. I gave you the area of the square to be 50 square inches in this case, all right? We're going to find the perimeter. Ooh, did it say perimeter? It says find the perimeter, doesn't it, everybody? So what we got to do is find a side, and then we got to have 4 of those. We've got to have 4 of those. So we're going to either multiply by 4, or we're going to add 4 of them together. So let's see where this is going to go. And another key expression here, we're going to leave it in radical form rather than trying to make a decimal out of it, okay? We're going to leave it in simplest radical form. So let's see what we have. I have s squared equals 50. And as we said, you know, if that had been 49, we'd all be excited because it'd be 7 times 7. We'd have a perfect square. 50 is just a little too much, a little bit over. So in my mind, I'm thinking that's going to be a little bit higher than 7 if we run it as a decimal. But let's do what it asks for, simplest radical form. So here we go. We're going to square root both sides. We're going to square root both sides. And when we square root s squared, we get one side back. All right, there it is. When we square root 50, again, we said it doesn't come out exactly perfectly even, all right, because it's an irrational expression here. The square root of 50 is irrational. So let's do our simplification moment. Let's break it down into, how about it, 25 times our 2. There we go. Because that is like 50 cents there, all right? So 25, think of it 2 quarters, all right? 2 times 25, or 25 times 2. 25 is a perfect square. If square root is 5, bring it to the outside. We're going to leave that 2 behind. So that 5 and that s begin to look a lot alike, don't they? But that is 5 roots of 2. That's one side. That's one side. Now remember what I said. A square has all 4 sides that are the same length. So easy way to do this, how about it? 4 times we'll take our 5 times the square root of 2. We're going to quadruple that. That's another way of saying it could be 5 plus 5 plus 5 plus 5. You get that in your mind? Hey, that's not hard to figure out, is it? The same thing here. We would say 4 times 5, which would give us 20. And folks, be careful. The root of 2 is not affected because it's protected, so to speak. The 4 takes care of the 5, but it does not work its way in with the 2. So there's your final answer, 20 roots of 2. Another quick note on that, if we had taken 5 times the square root of 2 and written that down 4 times as such, notice we've got here like terms, 5, 5, 5. We pick up also 20 times our square root of 2. So there is your perimeter in simplest radical form. And there you have it. A couple of ways to figure it out. You could multiply it by 4, it works nicely. You could add them like radicals and put them together. And you would still get 20 times the square root of 2. All right. So when we look at these problems, you're thinking, ooh, we got to remember our rules for radicals. Exactly. We do. And in this case, when we have like radicals, we can add them together. When we don't, we can't. All right. And got to remember how to multiply. Speaking of which, let's look at another good old problem here. A rectangle, if we'll think about it here. Dimensions of this rectangle are 5 times the square root of 5 and 6 times the square root of 5. We're not saying which is the length, which one's the width. Don't worry about it. They're just the 2 dimensions, all right? And when it says to find the area and the perimeter, let's take a look at this, all right? Formulas, so much easier if we use our formulas. How about it? Let's pick up area equals, I like to say, length times width. Again, in this case, it doesn't matter. And by the way, many of us think that the length always has to be longer than the width. That's not really true, all right? Rectangles can function however they want. Those dimensions are interchangeable depending on how you locate your rectangle, how you draw it, whatever, all right? In this case, we're just going to run them through here, okay? And let's see, we are going to take 5 times the square root of 5. Now we'll put a parenthesis around that, so I know that's one of my dimensions, all right, in its entirety. And then we're going to come along here, we're going to say 6 times the square root of 5. And that's going to be my other dimension, all right? Now notice I didn't give you units on these. I didn't tell you if they're millimeters, if they're centimeters, inches, feet. Just remember, when we run this in the end, the units will be square units, all right? When we run the area on this, just keep that in your mind. Now speaking of which, remember what we do. We multiply the numbers outside together. So we've got 5 times 6, which is going to give me a big old whopping 30. That's a good deal. And inside we've got this square root of 5 times the square root of 5. Now, a couple of ways we can go on this. Some of you are going like, okay, the numbers are under the radical. I want to multiply them together, and I'm going to get 25. Well, let's do that, okay? And you know what? The square root of 25 is a nice perfect square there. So we're going to have 5. No radical left, just 5. So wow, that's pretty nice. 30 times 5, because that gives me 150 square units. Now some of you said, well Ernie, could we not have just gone ahead and seen that the square root of 5 times itself is going to simply give us 5? If you've been watching Mathline lately, you know that's true. So you could skip this step. You could go straight to the 30 times 5, even maybe do that in your head, but you do come up with 150 square units. Now, let's see if your calculator knew to do that. By the way, does that bother anybody that you had 5 roots of 5, 6 roots of 5? You see all those good things, and you actually come up with a rational number, 150? That's kind of crazy, isn't it? It's crazy. Multiply an irrational times an irrational, and we get a rational. Let's see if your calculator knew that. Put a parenthesis around it, or our calculator. You may not have one of these, but I hope you do. They're fun. They are fun. So let's take the square root of 5, close the parenthesis, and close the parenthesis saying that we've got that factor, okay? That would be our length or our width, whichever way you want to call it this time. We put in the other dimension, which is going to be 6, and we're going to ring on that root of 5, play with it, and again close it. Close it. There's your second factor. And let's see where we go. Woo, 150. 150. Now, notice what I put here. I put u squared. That just simply means units squared. So if I had feet, be square feet. If I have yards, square yards. Miles, square miles. You get the idea. That's the deal on that, all right? So when we don't get units given to us in a problem, and a lot of times we don't, that's what we're playing with, all right? We're just going to call it whatever square units they are. Now, part 2 of this problem says, let's find the perimeter. Let's find the perimeter. Well, the formula for perimeter, P equals, let's see, how about it? 2 lengths plus 2 widths. It's a rectangle. So we're basically going to add all 4 sides together. There are 2 lengths. There are 2 widths. Everybody good on that? Y'all with me out there? Keep writing. Keep working. So let's see what's going to happen. And by the way, notice we lost our radical. We lost our square root function here. The question is, will we lose it over here? All right, let's see what happens. We're going to put in 2 times, how about it, 5 square roots of 5. We're going to put 2 times 6 square roots of 5 there. And you know what we're going to have this situation where, you know, we got to multiply 2 times 5, which is giving us 10, but leave the square root of 5 there. We'll keep the square root of 5 right there, okay? It doesn't change. Move along down beyond it here, we've got 12, and again, the square root of 5 hangs on for dear life. And you know, our final value looks like there's going to be 22 square roots of 5. That's your perimeter. And you say, Ernie, what is that as a decimal? Well, let's see. Let's clear off my calculator, and we will get you a decimal out of that, all right? Those of you who like to know what it is in nice decimal terms, and I'll be honest with you, if you're looking for a length or a width or a perimeter, you tend to want it into a decimal form. All right, so let's see. We're going to take it square root of 5, close it, and let's see what we get. Wow, quite a big number there, almost 49 units. Now, that's not square units, people. That's not square units. You're going like, wow, that's almost like 7 squared. Well, it actually looks like it's close to it, right? But remember, this is linear measurement. This is as you travel around. So this is how much space you would go around. So in this case, if it were feet, you'd be walking around a rectangle of about 49 feet, okay? If it were miles, it's a lot of rectangle. It's a lot of rectangle, all right? So again, those units are not squared on the perimeter, but they are on the area. So be sure you keep that straight. Keep that straight. All right, let's take a look at our next problem here. This one is back to our rectangle friend here. It says the diagonal of a rectangle is 30 millimeters. And the rectangle's length is 24 millimeters. What's the width of the rectangle? All right, what we've got going on here, if we create a little rectangle here, let me give you one. There's our rectangle, pretty close. Remember, they have all these lovely right angles. And according to this, we already have a diagonal working through there. There it goes, connecting. That's our diagonal there. And according to this, the diagonal is 30. And it says our length is 24. I'm going to let our length be the horizontal moment here, all right? The question is, what is the width? What is this little guy out here? Now you say, what does this have to do with square roots? I don't see any radicals there. You could. There could very well be some. And on down the road, there might be on some of our Mathline problems, okay? But for right now, we're looking at this, what do we do? What do we do in this case? Well, what we've done, we've created a right triangle. Now, some of you are saying, well, Ernie, could we have done it with the 24 here? Sure. We create 2 right triangles. They're going to be the same length. In this case, they're going to be the same width. They're going to be the same measurement. All right, same number's going to fit in there. So let's see what we're going to do. We're going to use our good old friend, you know, the one named after Pythagoras. You got it now, right? We're going to use the Pythagorean theorem to solve this out. Because it's a right triangle, and we know 2 sides, we can find the 3rd side very easily. So let's do it. We've got w squared plus, all right, where are we going? 24, exactly. 24 squared equals to our good old friend 30 squared, all right? Now, in looking at this, we have 24 squared. You know, I love to make my students learn their perfect squares, but I usually don't take them all the way up to 24. Usually up through 20 is where I go, so let's see what that does for us. 24 squared gives us 576. I thought that was what it was going to be. Now, 30 squared, we can do that in our head. 30 times 30 gives us 900. Remember, add that extra 0. Don't put 90 out there. You'll have some strange stuff, that's for sure. But let's see. We want to figure out what is, and I'm going to use the calculator just to make sure we don't make a mistake today. How about that? It's a Friday and we don't want to make mistakes, do we? We're going to subtract that 576 from 900 and see what we have left over. Nice number. That's what I was hoping for. You say, Ernie, why do you say it's a nice number? That's a big number, isn't it? Actually, it's a perfect square. As you remember our early shows, we emphasize these perfect squares. And here we go. The width is equal to, there you go, 18. So, perfect square, but we had to use square roots to get out of this. Another application, another great application. By the way, another question that could have come from this, we could have asked, what's the perimeter? What's the area? Because once you have, folks, length and width, you've got a lot of things you can do. A lot of ways you can make the problem real easy. But the key thing is noticing right triangles, Pythagorean, square roots rock. Square roots rock. They are. So some good geometry applications running there for you. Now, let's take a look at our next one here. All right, got a problem here where we have the rectangle, one more rectangle. It has the length of 3 roots of 16 and the width, is 5 roots of 3. Guess what? They aren't the same root, are they? One's a root of 6 and one is a root of 3. That's going to make some interesting happenings here. It says find the area and find the perimeter in simplest radical form. Let's go for the area first, folks, all right? Again, that formula, A is equal to our length times the width. You got that? Let's put in what we know. We have, pretty stuff here. First one, we're going to call it 3 times the square root of 6. That'll be our length. Our width, we're going to call it 5 times the square root of 3. Again, we don't have units on this, but maybe they could be inches. They could be any kind of units. Remember, our final result will be square units. Let's see what happens. Let's see what happens. And we'll leave it in simplest radical form. Very important to know that. So see what we do. We multiply the 3 and the 5. 3 and the 5 there together. That gives me 15. And inside the radical, I've got a 6 and a 3 that want to multiply together. That gives us a root of 18, square root of 18, which is, you're probably going, Ernie, I don't think that's simplified. You're right. We can simplify that 18. Let's see what happens. We got 15. Think about the factors of 18. Think about them. Well, 1 and 18 don't help us any. 9 and 2 are good. You know why? Because 9's a perfect square. So let's pop in that 9. Bring the 2 out there for the ride. And you know what? What's the square root of 9 out there, folks? You got that on the tip of your tongues? Of course you do. It's 3. Now, what are we going to do with that 3? We're going to bring it and multiply. We're going to multiply in with that 15. That's going to give us 45, and we will have a square root of 2 left over. Now, remember, that is whatever our units squared are, all right? Whether feet square or miles or millimeters, centimeters, all sorts of good things. That's our situation. Now, for those of you who like to know what it is decimal-wise, hey, hit your calculator and round it off somewhere, all right? Because it will be irrational. The root of 2 is messing things up for us there, all right? Now, second part says, let's work out the perimeter. Let's go for 2 length plus 2 width. And folks, that will give us the perimeter. That will be our perimeter, all right? So let's see what happens. I have 3 times the root of 6. And I'm going to take 2 times 5 square roots of 3. That look good? We got the right length, the right place. Perfect. Equals P, a perfect perimeter. Well, an interesting one at least, that's for sure. Some of you are going, this doesn't look so perfect to me. Let's see what happens. We've got 6 times the square root of 6, plus 2 times, that's going to be 10 square roots of 3. Equals the perimeter. Now, folks, it's tempting. Is it tempting? You are finished with the perimeter there. That's as far as you can go. As far as you can go. Now, let's see why. Because you've got a square root of 6 and a square root of 3. It's got to be the same radical. That's like saying a 6x and a 10y. It doesn't go anywhere. All right, so again, you've got 6 times the square root of 6, 10 times the square root of 3. Definitely a moment where you would want to put that in your calculator. Let's see what the real perimeter is. We're about to run out of time, so we're not going to go there. But I want you to, once again, understand there is a rule for your radicals why you cannot decide that's going to be like some of you want to do. Okay, we call that 16 square roots of 9, and yay, we'd have a nice rational number. Doesn't work that way. These are like apples and these are like oranges. Got to keep them separate. Got to keep them separate. Hey, thank you for tuning in this afternoon to a great summer school program. I think so. Lots of applications, important applications you're going to see in your classes in algebra, geometry, and on up in there pre-calculus and such. So a good start there. More radicals, more radicals. Hey, we're glad you've tuned in all week. And you know, we'll be back again next week. More summer school. In the meantime, you'll have a great evening and a great weekend.